invited to be the facilitator of this session and to be part of the first event by Toddle for the DP, the Thinkathon. I hope that you will walk away with a deeper understanding of the internal assessment criteria, and this session will be up to your expectations. So with no let's get started. The objectives of this session is to develop a clear understanding of the application of the internal assessment criteria, identify elements and of strength and weakness per criterion, and at the very end, we will together explore ways to prepare students for this assessment task. So let's get started with the basic information. The internal assessment can take, like the investigation, can take different formats. The most common one is the hands-on laboratory investigation, but also we have seen a rise in the use of simulation-based IA. The IB has requirements for the simulation and what type of simulations can be useful for the IA, and you can find these on the teacher support material. The simulation needs to be interactive and open-ended, allows for variance in the results. Also, another form is the database type of investigation. And the last one is like the spreadsheet, using data from the hands-on laboratory investigation or from a database, and then use the spreadsheet to find a mathematical model for this data. The IA time allocated as per the IB requirements is 10 hours. Most of the 10 hours should go for the action phase, the experimentation phase. The IA is expected to be a report of 6 to 12 pages. However, we do not penalize the students if they go over 12 pages, as long as the report is concise, focused, and there is no repetition or irrelevant material. The IA is internally assessed by teachers and externally moderated by the IB. However, for the last 2 years and this year as well, the IB has required schools to upload all IAs, and they will be treated as if they are external assessments. The IA contributes 20% of the student final grade. The requirements for the IA are the same for both standard level and higher level, and they are, they share the same assessment criteria. And these criteria, they are 5: personal engagement out of 2 marks, exploration, analysis, and evaluation, each out of 6 marks, and communication out of 4 marks, thus leading to 24 marks in total. Before we move on to the criteria itself, let us explore the format of the rubric and the level descriptors, the use of mark bands, and the best fit approach for marking. So this is like how the criterion structure looks like. There's always in the rubric statement of the criterion, the different performance levels with the descriptors. We also call them indicators. They vary between 3 to 4 indicators or descriptors per performance level. Some performance levels, they have only 1 mark, others they have 2 marks, but this is the general structure. For example, this is the rubric for the analysis criterion. You can see that some words are bolded, and there are like 2 marks per mark performance level, and there are 4 descriptors per level. How do we use the descriptors? The IB guidance is that when we, and this is the guidance is for both teachers and moderators alike. So we are always reminded that we should read the level descriptors from the lowest upwards until we identify the descriptor that best describe the level of the student's work being assessed. If a piece of work seems to fall between 2 descriptors, then we need to go back to the student's work, collect more evidence that would support our choice for one or for the other. Now, for the levels where we have 2 marks, teachers should award the lower mark if the quality or the work of the student demonstrate qualities of the descriptors to the less extent. In that case, they are closer to achieving the lower band rather than the higher one. Vice versa, we should award the higher mark only if the students' work demonstrate the qualities described to a higher or greater extent, and they are closer to the upper mark band or upper level. One very important criterion that teachers often miss is that the highest level descriptor, the 6, is not meant for perfect, faultless work. No, again, we go back to the descriptors being met to a great extent. We do allow students, work that has some inconsistencies, but it is really excellent to be awarded a full mark for the criteria. Only whole numbers should be recorded, and we should not really think of pass or fail. We should always concentrate on identifying the appropriate level descriptor. Now, when we come to determine the overall grade for a certain criterion, we use the best fit approach. Well, it is not often that we find all the descriptors or indicators in the same performance level. We find them like scattered across the different levels. We also may have one indicator or descriptor that is totally missing. This is why we use the best fit approach. The IB describes the best fit approach in the guide. It means that compensation should be made when a piece of work matches different aspects of a criterion at different levels. The mark awarded should be one that most fairly reflects the balance of achievement against the criteria. This is what we mean by holistic judgment. For instance, we may have a work where the first, and this is the analysis criterion, the first and the second descriptors, they are in the 5-6 performance level, whereas the third and the fourth descriptor, they may be in the 1-2 level. They are not adequately, addressed by the student. Even though the work is in the 1-2 and the 5-6, the overall assessment is best to be described in the 3-4 performance level, even though these students' work really lies in the 5-6 and the 1-2 performance levels. This is what we mean by best fit approach, and this is how we apply to all criteria. Let us move now to the criteria itself. So we have 5 criteria, and these are the statements of the criteria. And I would like at this point to Pavali to run a poll to get a survey of your opinions about which of the criteria you find most challenging to assess. Is it personal engagement, exploration, analysis, evaluation, or communication?
Right, and the poll is live now. So if all of you would like to just quickly type in your responses, that would be great. I hope everybody can see the poll. In case you're having trouble accessing it, can you just let me know in chat? Okay, we'll give it another couple of seconds before everybody finishes. We've got, most of you have responded, so. All right, that's perfect. I'm just going to close this and share the results with everybody. There we have the results, Nada. 40% of the participants said personal engagement is most challenging, 30% said analysis, and another 30% said evaluation. Exploration and received any votes.
Okay, great. So this is in a way very consistent with what I find in the workshops. Most participants find like the personal engagement to be very subjective and hard to assess. So let's start with the personal engagement. This is the criteria for the personal engagement. You will see a lot of words being bolded. And there's only one mark per performance level. And these are the descriptors that we are going to check. There is the first one, significant and independent thinking or creativity. I will highlight the word or. There is justification for choosing the research question and or topic demonstrating personal significance, interest or curiosity, evidence of personal input and initiative in the designing, implementation, or presentation of the investigation. When we are marking the IAs, we look for the following points and we consider them to be areas of strength. There is like a strong personal engagement. There is a genuine personal interest that can be sensed throughout the whole report. It is, I really underline the word genuine and sensed. It doesn't have to be explicitly mentioned. Actually, the personal engagement should be, and personal engagement criterion is the criterion with communication that are holistically assessed. We do not look for it in a specific part of the IA. We read the whole IA once and twice in order to determine the mark for the personal engagement. So it is marked the last one to be marked. Evidence of independent thinking throughout the report. The creativity would be in the design of the method or in modifying an already traditional investigation, the procedure of a traditional investigation. Conducting a preliminary investigation and using the results to tweak the method, to tweak the approach, and including it in the report is an indication about the personal input and initiative of the student. Combination of various approaches in the meaning that like a student can have a traditional laboratory experiment, but at the same time runs a simulation and then compare the results of the investigation to the simulation. This is the combination of various approaches. It also tells us about the initiative of the student and their personal input. A thorough scientific context for the research question and for the conclusion. When the student really has a strong theoretical background, this sets this theoretical framework for the whole investigation and grounds the investigation in theories. And this is very important, along with the choice of valuable sources. When the sources are really valuable, they are like from refereed journals, and they are used in an effective and an intelligent way throughout the report. Thoughtful techniques, innovative techniques as well, used in analyzing the data. Reflections on the quality of the collected data and the limitations. Deep understanding of the limitations of the investigation, suggestions for improvement that are not just outlined or described, but they are justified and they give insights about how the results can be improved to make them more in line with the scientific accepted results. These are the elements of strength that we look for. Now, for the weaknesses that we usually notice in students' IAs with respect to personal engagement, overemphasizing personal significance or like by including comments that are really artificial. The subject report often advises students and teachers to instruct their students not to specify a section for personal engagement. The personal engagement, again, should stem throughout the report, being authentic, being genuine, because of like you have a very thorough report. If the candidate chooses a very simple research question, then this is a simplistic research question. that the outcome is very well defined and found in the syllabus, self-evident, then this is a sign of lack of curiosity and personal input, really. The report describes a commonplace school investigation that is widely available on the internet, or we see, like many cases, students using prescribed experiments, or experiments that are exemplars on the teacher support material. We don't penalize the students for these choices, but then they will score low on the personal engagement. The data that is being collected seems to be not really demanding at all and does not justify an action phase that should take the most of the majority of the time allocation of the 10 hours. This is another sign of weakness. I usually receive in my workshops specific questions about the criterion, PE criterion. One of them is that, like, how does the moderator know about the personal engagement when it's the teacher who is supervising the work? And what input can the teacher bring to the evaluation of the PE? Please note the following, that the moderator determines the PE grade based on the evidence found in the report itself, as per the 3 indicators, descriptors we just talked about. However, the teacher's comments are really valuable and we read them all the time, especially if they shed light more on things that are not very evident in the report. However, if for the comments to be really important, they really need to be personalized and detailed and connected to the descriptors. For example, if the student did run a preliminary investigation and use the investigation to improve their method, and this is not included in the report, a comment to this account can really help us to have an idea about the initiative of the student. And we often take good comments from the teacher to give the benefit of the doubt to the students. So please write personalized comments. And paraphrased comments, the comments that paraphrase the descriptors themselves, they are not of use at all to us, and we don't take them into consideration. Another question that is often asked, does the rework really need to be totally original to score the full mark? No, not really. The subject report of May 2020 speaks it out very clearly. Performing an investigation with a standard method and a standard analysis, but in a thoughtful, detailed, and competent way, a student can earn the full PE grade, the 2 marks. So we're looking for a thorough work, deep understanding, thoughtfulness. This is what we are looking for. Another question, in what cases does a student get a 0 out of 2? Very rarely. Only the student has to do a lot of work in order to receive 0 out of 2. So they really need to have, like, a title, very incomplete research question, maybe a qualitative, not quantitative, dependent variable, very brief method that is incomplete, insufficient data, lacking a conclusion, or, then yes, they will earn the 0. So we don't give zeros that much. However, we notice that teachers give more zeros than we do. I hope like this helped address the PE criterion. Let's move on to the exploration. I'm glad that no one found the exploration to be an area that is challenging. Again, we deal with 4 descriptors. The first one has to do with the research question. The second one with the theoretical background and setting a theoretical framework for the investigation. The third one is for the methodology and taking into consideration the significant factors that affect the reliability, relevance, and the sufficiency of the data. And the last descriptor is not a must. It's only a must when it is really appropriate. And it has to do with the showing awareness about safety, ethical, and environmental issues. Let's get started with the first descriptor, which is the research question. First of all, it does not have to be a question. It can be a statement. Strong research questions or statements, they are clear, they are focused, and they aim to investigate the relationship between two variables or, determine an important scientific constant. They include a single well-defined variable, independent variable. And I would like to stress and underline this point. And a quantifiable dependent variable. Weak research questions, they are usually not well-worded, vague, not fully focused, or they might be focused, but not really relevant to the identified topic. They include multiple research independent variables. Many students seem to think that the more if they have two independent variables, then this will make their chances of getting a higher mark bigger. It's not correct. It's just the opposite. Because multiple independent variables will lead to two or more investigations within the same investigation, and this will inhibit having a thorough investigation. Unquantifiable dependent variable, it dooms the whole investigation because the investigation is quantitative after all. Simplistic research questions that are totally undemanding. We know the outcome already. How does the length of a wire affect its resistance? This is a very simplistic research question. The second descriptor has to do with the theoretical background. For strong theoretical background, it's like it makes uses of known scientific concepts. They are well explained, but they are not broad or like just touching the surface. They focus on the concepts that are relevant to the research question. They include relevant equations. And whenever the equations are within the reach of the student and like in the syllabus, then we expect the equations to be derived and to establish a relationship and not just stated. Theoretical backgrounds that are weak are usually very broad. They give general accounts. They don't focus on the research question. They include not real solid scientific theories, but more of made up physics-like explanations. They tend to have also historical backgrounds. Some of you would say that Nada, like historical backgrounds affects the communication because they make the report not really focused. True. They are mainly will affect the communication part. However, if you have like the theoretical background, big chunk of it is historical background, and then very little theory, then this will impact the second criterion, the theoretical background criterion. I would like to mention though, something many students, they include at the end of their theoretical background, a hypothesis. The hypothesis is not a requirement. However, if the hypothesis is included, then it will be a strong hypothesis if it is based on the theory, rather than it's an informed guess, rather than just a guess. And it is like, it does not mention if X increases, Y increases. It does provide a clear relationship. Whereas a hypothesis that is weak would be like made up hypothesis, just pure guess, and qualitative descriptive a relationship that if X increases, Y decreases, or so on. With regard to the third descriptor, which is the method, a strong method would be fully described with attention to detail and consideration of independent, dependent, and controlled variables, as well as the variables that cannot be controlled. Please note that the student is not required to have a table with the independent, dependent, and controlled variables explicitly identified. This is not a requirement. If they are attended to within the method, then this is fine. The method does not have to be bulleted. It can be written in as a paragraph. It's fine. A strong method will allow for sufficient and relevant range and intervals of data with enough repeats to establish reliability. And this is mentioned in the, should be mentioned, referred to in the method. The choice of the smallest value of in the range, the size of the range, the equipments as well, how they account for to reduce errors, whether calibration of some equipments, the choice of the precision for other for equipments, how like the repetitions, they are included as well. The use of control experiments in a way to tweak, as I mentioned before, if they make some runs at the beginning, and from that, they can be informed about tweaking the method. It is worth mentioning this. It will be a strength point for the PE as well as the exploration. If there is room for qualitative observations, then provision for that would be an element of strength. In case of databases, video analysis, simulations, the use of screenshots to explain how the data was captured is essential. Weaknesses, you know, simple, overly simple, imprecise methodology, lacking important information, method not sufficiently controlling the variables, method that does not generate sufficient or relevant data, method does not consider factors that may influence the reliability of the collected data. I would like also to mention that here, that if the method is not well written, we do not penalize it here in the exploration. If it's not well written, we penalize it in the communication, as long as it does attend to the sufficiency and the relevancy and the reliability factors that may impact the conclusion. With regard to the safety, ethics, and environmental impact, we mention it only when appropriate, and for like safe handling of equipment and chemicals, correct disposals of waste, and or sustainable consumption of materials. When the investigation does not call for these issues, a simple note to that account is enough. Students should not really fake up or just add superficial or irrelevant note just to make sure that they have addressed this criterion. Saying that it does not apply is perfectly fine. Now, with regard to the analysis, and 40% or 30% acknowledge that this is an area that is a bit challenging for them. Again, we have 4 descriptors. The first one deals with the raw data and the sufficiency of the raw data, both quantitative and qualitative when applicable, that could support a detailed and valid conclusion. Appropriate and sufficient data processing carried with the accuracy required, and consistency. Evidence of full and appropriate consideration of the impact of uncertainty, as well as the interpretation, the last descriptor. So let's get started with the strength when it comes to the raw data. We need to find in the report a table with the raw data there that is relevant to the research question, enough to support a conclusion. Now, the guidelines say that a minimum of 5 values for the independent variables for a linear relationship. I require at least 8 from my students. 5 for me, I don't consider them to be really, it's borderline, very borderline. And in the case, as one of the, later on, the data points comes out to be an outlier, then this will jeopardize the sufficiency of the data. If there is the nonlinear relationship, then you need way more data. Enough repeats, 3 to 5, depending on the precision of the data. Reading uncertainties and units, they are included in the row uncertainties, they are included in the tables. We need to see them, they are part of the analysis. With regard to the third descriptor, processing, we need to have a correct and complete processing of raw data. Sample calculations only for complex calculations, because if it's going to be like wary calculations, every single thing, this will affect the focus and the conciseness of the report, and that can affect the communication mark. Now, many students should use spreadsheets in order, or Google Sheets, to do the calculations. In that case, the students are not required to get like, to show the Google formulas or whatever. No, not at all. The processing includes finding mean for the dependent variable and then plotting a graph to see the nature of the relationship. This is part of the processing criteria or indicator. Well-constructed best fit lines, and I will talk a little bit about this. Many times, and I will address this in the weaknesses, many times like the best fit line calls for a curve, and we see forced straight lines are being used. Or the best fit lines, the students choose blindly the best fit lines with the highest correlation R-squared value, and whereas it's not the correct accepted relationship in the theory. So extra care should be taken on choosing the best fit lines, and we need to see the equation of this best fit line as well. So the weaknesses when it comes to the raw data not being relevant to the research question, it does not really address the research question, or not enough to support a conclusion, or not enough even to, like, as I said, if there's an outlier, and then if it's only 5, then it becomes not enough. Processing graphs lacking appropriate detail or too small to read properly. Some of you would say, Nada, but this is more of a communication. It does, yes, it is mainly communication, but if the graph is too small to see important details, then this will impact the moderator's ability to mark this descriptor. So it will impact as well the analysis criteria. As I was saying, forcing a linear best fit line when the data suggests a curve fit, thoughtless adoption of the Excel best fit equation, not really thinking about it. Representing graphs, we often see graphs, but where is the equation? We don't see it. These students refer to an equation that is not there. I would like also to talk a little bit about, again, about the best fit lines that are blindly using the high R-squared value and not checking whether it fits well with the theory. And I would like to jump ahead and give an advice on how to address this with the students. Most of us do like the pendulum, a simple pendulum investigation with the students, where the students investigate the period, relationship between the period and the length, and often students there choose the R squared, the best fit line with the highest R squared, but it is not the correct equation. So drawing their attention on being critical with the use of the R squared, not just blindly adopting it, the highest one can be very useful when we are teaching the students the skills. With regards to the uncertainties, we look for the following evidences. Reading uncertainties or the raw uncertainties, uncertainties of the average values, whether using range divided by 2 or standard deviations, sensible protocol on propagating error through numerical calculations. We look for error bars on a graph, evidence of error bars on graphs, maximum and minimum gradients to calculate the slope or and some uncertainty of the slope, or the uncertainty of the constant that they will be calculating from the slope. Appropriate consideration of outliers, and to that aspect, students should first draw the graph with the presence of the outlier, find the best fit line, the equation, describe the impact of the outlier on the line, maybe not passing through all the error bars or whatever, not really making, not being aligned with the theory. And then they propose removing the outlier, and this shows us the thinking, the independent thinking of the student, and this I take you back to the personal engagement. This is how students show independent thinking. And then they remove the outlier, they graph again, and they comment again on how now close the relationship of the best fit line equation to the theory, how the best fit line goes now maybe through more error bars than before, etc. Full consideration of significant figures and decimal places, comparison of calculated scientific constant with accepted value to evaluate variance. So if we have an accepted value that is available in the literature, the constant that the student is calculating, they should calculate the percentage error or the percentage difference between this, the calculated value and the literature value. When it comes to weaknesses, either no consideration of uncertainties, we see missing uncertainties in raw uncertainties, but the real problematic ones is not really questioning unrealistic error bars. We see huge error bars, and the students doesn't occur to them that this cannot be the case, that there is something wrong. They maybe made a mistake in calculating those error bars. Construction of minimum and maximum gradients that are totally unrealistic, totally extreme. They make no sense to the graph. And this is where, like, we see that the students, as if they are checking a checklist rather than being really understanding what they're doing in the processing and in the analysis of the data. Or, for example, when there is room for propagating errors and they are not propagating the errors. For the last descriptor, interpretation, data is used to find relationship or value. Now, the equation is there, the best fit line is there. The students should, first of all, describe the graph, comment on the trend in the graph. What do they observe? What patterns they observe? They need to, like, compare their graph to the an expected graph as per the theory. They can even draw it on the same another graph with the like the experimental one and the theoretical one. That could be excellent. There is like evidence that they explain the impact of the uncertainties. They refer to the size of the error bars. They refer to the y-intercept or the x-intercept. They refer, if the relationship, the ideal relationship is direct proportionality, they would maybe comment on whether the origin is within the y-intercepts of the maximum and minimum gradients. So everything that is related to interpreting the graph, the results, is like the more thorough it is, the stronger the analysis would be. Weak interpretations, we often see that the students abuse and misuse, confuse the word proportional and linear. When the data and the graph, like it is a linear relationship, they refer to it as proportional relationship, or they interchange the use of the words. No reference to mathematical error analysis when interpreting the physical meaning of the data. No mentioning of the size of the error bars, no mentioning the meaning of the y-intercept or the x-intercept. No, they don't interpret the fact, what is the meaning of the best fit line not passing through all the error bars as well. The overdependence, and I already talked about this, overdependence on correlation coefficients in order to establish relationships between two variables. I would like also to add like that whenever students, many students, when any curve, they refer to it like as exponential. Like there is an exponential, this is graph. And many times they refer to, they identify the graph to be something that is totally different than what the equation of the best fit line indicates. Here I would like to pause and address a perceived overlap between exploration and analysis. You may have noticed that the term sufficiency of relevant data is found in both exploration and the analysis. Is that an overlap? The IB says no, this is not an overlap. And the IB guidance is that we should consider the sufficiency of relevant data in the exploration in a different perspective than we should look at it in the analysis. So we need to consider it from different aspects in both criteria. Under exploration, a very important statement here takes into consideration. It makes the whole difference. Takes into consideration is simply acknowledgement. The student only needs to acknowledge the significant factors that influence the sufficiency of the collected data in the method, such as making reference to the scope and range of data, the choice of the smallest value and the highest value. And if there are like, you know, limitations due to a narrow value, range, sorry, due to the equipments or the nature of the investigation itself, as well as the number of measurements within the range. Making accounts of this, acknowledging this in the report means that the students took into consideration the sufficiency of the relevant data. When it comes to analysis, we need to see it there. We need to see a table that has enough data, raw data, that has relevant as well data. It's not only enough, but also relevant to the research question, enough to draw a conclusion later on. With regard to the evaluation, We have four descriptors. The first one is the conclusion in the context of the research question being supported by the data. The second one, the conclusion with compared to the scientific context. The third one has to do with the strength and weaknesses of the investigation. And the last one has to do with the suggestion for improvement and extension of the investigation. I'm going to consider both the first and the second descriptors together, conclusion and scientific context. Strong conclusions always start with recalling the research question, connecting us back to the research question. What does it say? And a statement or a discussion to that account. Does the result, the results, the data, do they answer this research question? So it's not enough to say that as a conclusion, we try to investigate the relationship between X and Y, and we can say that X is directly proportional to the square of Y. It needs to be backed up by the results. They need to get the equation and put it in the conclusion. Show it again. If there is like a calculated constant, they need to bring that calculated constant and refer to it again. The moderator should not go back up and down. They need to see it there in the conclusion. And also, I would like to mention that if the student had made a hypothesis in the theoretical background, they need to go back to their hypothesis again in the conclusion. The findings need to be connected to relevant scientific context to provide justifications that these findings are reliable, or to show awareness how they deviate from theory. So it's not enough just to defend your conclusion based on your data. You need to compare it to the theory. What does the theory say? Is it in line with the theory? Does it deviate from the theory? And there's nothing wrong, like students think that if it deviates from the theory, then their investigation will not get a high score. This is not true. As long as they show awareness how it deviates and they discuss possible reasons, that like in a thoughtful way, then they are fine. Calculated values are compared to accepted literature values when available. Weaknesses is like, the conclusion is maybe not that relevant, not that well connected to the research question. It does not really answer it. So it's very important that the students recall their research question when they are about to conclude. Also, like we often see that there is a hypothesis in the background, but then it is not referred to in the conclusion. Conclusions being simplistic or just qualitative, when X increases, Y increases or decreases, without really giving a quantitative relationship. Conclusion not being evidenced by the results, like the results show like maybe a certain relationship, and then the conclusion is that like it is directly proportional when the data shows something different. Conclusion not being supported by the theory, values not being compared to available accepted literature values. With regards to strengths and weaknesses, many students address the weaknesses, but rarely address strength. It is like important to celebrate the strength of the methodology, not the procedure, the methodology. If the error bars are small, what does that mean? If the calculated value is very close to the accepted value and the percentage difference is very small, what does that mean in terms of strength? The weaknesses, they really need to be related to the methodology in order for us to consider them a strong aspect of the descriptor. And the underlying assumptions, if the assumption like there is friction and the underlying assumption is to neglect friction, okay, what is the impact of that underlying assumption? Also reflecting back on the sample size, the range of the data, the choice of the apparatus, maybe the method itself not being that adequate for this type of investigation and why. As long as they are not just outlined or described, you know, the outline, when they outline stuff, even if they are like meaningful, but they are only outlined, then they are in the maybe 1, 2, 3, 4 maximum. Described, they are in the 3, 4. In order to get to the 5 and 6, we need discussion. An evaluation of the nature of the experimental errors, random, naming the errors and naming them correctly. And this is random error, this is systematic error. And that are consistent with the findings, like often, and this could be like considered in the weaknesses, often like students use the word precision and accuracy interchangeably, or like they use random errors and systematic errors interchangeably, and this is a weakness. They identify like maybe they would say overstate certain errors that are not really relevant. If the error bars are small, then talking about like there is a lot of you know, random errors does not make any sense anymore. So weaknesses would be referring to practical or procedural issues only and not methodological issues. And as per the subject report, if the weaknesses, identified weaknesses, are only procedural, then this will automatically put the student's work in the 1-2 performance level. It will not go to the 3-4.
And I was just wondering if you wanted to take a bunch of questions before you move on to the next part.
I'd rather to finish the communication because we will finish then the whole.
All right, perfect. Okay. All right.
So referring to sloppy manipulative skills, this is practical and not methodological. Overstating the impact of errors that are not really relevant, such as parallax errors, or as I said, if the error bars are really small and talking about, wow, making big deal out of random errors instead of considering that to be a strength. And the suggested improvements, as long as they are like precise, relevant, focused to the investigation, they are related to the identified weaknesses. They are like really discussed and not outlined again. And they serve to bring the experimental results closer to what is expected. Then this they would consider to be strong. The suggested extensions are fully discussed, because usually like it would be at the very end of the report. The extension is the last part of the report. And usually it is done in a hassle. So even like when they are really good suggestions, but if they are outlined or described, then they will not get the full 5-6 mark. Weaknesses would be like suggestions for improvement only address procedural, or they are cliche, superficial, generic. Take more when like, you know, we need to have more repetitions. When the more repetitions will not improve the quality of the data, you know, or like unrealistic, get more accurate instruments. What does that mean? Like, this is not a useful suggestion for improvement. Extensions just outlined. Sometimes, many times, they are just missing. For somehow, like many students miss the extension part or not being fully relevant. Here, I would like to pause again about a perceived overlap, which is the error analysis and uncertainties under exploration, analysis, and evaluation. Error analysis and uncertainties occur in these three criteria. But again, we need to consider them with different perspectives. Under exploration, again, students should take into consideration, acknowledge in the method, when they are writing the method, acknowledge the reliability of the data by showing awareness of systematic errors related to assumptions in the method, calibration of the equipment, precision, accuracy of information obtained from a database, etc. No numerical expressions of uncertainties are expected under exploration, only making reference to them. Under analysis, the treatment needs to be quantitative. We need to see absolute or raw data uncertainties in the tables. We need to see, like, determining the uncertainty of the average, propagating errors as well. We need to see error bars when they are applicable. But if they are not applicable, like the error bars are very, very small to be evident on the graph, the student should write a note to this extent, saying that the error bars are very small and could not be displayed. Or they can really put them, draw them there, and enlarge the, take a snapshot and enlarge it to show that they are there, but they are not visible. And this is how, like, they will get the moderator would know that they know how to analyze and process this. Establishing a gradient with its uncertainty for linear lines. Under evaluation, the error and uncertainties, and this is when we discuss the limitations of the error and the sources of errors and uncertainties. So we discuss this from different angles in each of the different criteria. As another perceived overlap between analysis and evaluation, conclusion is in the analysis criterion for every single descriptor. However, the conclusion here is different than the one in the evaluation. Under analysis, the conclusion refers to interpretation of the data, of the graphs. What trends do we see? What shape do we see? What does the equation tell us about the relationship? This is what we expect from a conclusion. Whereas in evaluation, the conclusion is the statement, the discussion that addresses the original thinking of the student, the research question. In other words, does the conclusion support the student's original thinking in the topic? If not, a consideration of why it does not will lead to an evaluation of the limitations of the method, etc. And you can find this in the teacher support material, guidance on the use of the internal assessment criteria. The last criterion is communication. And we have, again, different descriptors. With the structure and clarity, the first descriptor, structure and clarity, the research question is presented early on in the report. This is very important. And we should not like read first 2 pages and still wonder what is the student gonna talk about. The structure is evidenced by use of headings, subheadings, diagrams, images to enhance interpretation. The thinking process is clear to follow, easy to follow. Referencing of the ideas, graphs, accepted values. It doesn't to be a perfect referencing. It's not as strict as the EE, but there is like at least some expectations for referencing. Weak aspects of communication, poorly written. The poorly written methodology is analyzed here. But this is a minor thing, not including an investigation title, but it is an expectation to have a title. Unclear, unlabeled photograph of the setting. Many students think sometimes it's better to take a picture of the real setting that they have, but often the picture is not clear, it's vague, it's not labeled, it does not help us understand the setting. In that case, a clear sketch would be much better. Not acknowledging information taken from external sources, or having a list of references at the end that, you know, we don't know how they were used in the report itself. Conciseness, relevance and conciseness. The report needs to be concise and focused around the research question. We will not penalize reports, again, that exceed the 12 pages, 13, 14, 15. I marked like 16 pages, and we did not remove points or marks because they were really very concise and all information was relevant. But irrelevant information, very, very detailed, exhaustively detailed procedure that gets so boring. Having table of content like cover page, no, this is waste of pages actually. Specific terminology and convention, correct and consistent. The consistent word is very important, and we will see why. Scientific terms, units, reading uncertainties, formulas throughout the report. Appropriate formatting of data, clear and easy to read tables with proper headings, graphs with appropriate scale, labeling and appropriate size. Correct derivations of equations and well laid out. And the equations, talking about the equations, the moderator should not scroll 10 pages up to refer to an equation if it's mentioned like refer to equation 2.3, and then the moderator needs to scroll up few pages. Then this would be a weakness in the communication. Inconsistencies in the use of scientific terms, missing units, inconsistent reading uncertainties, significant figures, precision, everything. This is part of communication. Now, a question would be not recording uncertainties in the raw data. Is this penalized under analysis, indicator 2, or communication, indicator 3, or both? Whenever there is completely missing uncertainties, this is an analysis problem. This is why I all the time stress the word inconsistency. When it becomes inconsistent use of precision, of uncertainty, significant figures, then this is a communication issue and not an analysis issue. Okay. We're done with the criteria. Before I take your input on how we prepare students for the IA, maybe we want to take some questions. We have time, huh? To take some questions?
Yes, we do, Nada, and quite a few questions have been have come in already. So I'll start with the ones right at the beginning, because I know that people might forget back then. I know that some of these may already have gotten answered, but we'll just be doubly sure any which way. So the first one was from Venkat about 2 independent variables, and he was wondering if 2 independent variables can be investigated together.
If you refer back to the different subject reports, all subject reports warn the students or the teachers against using 2 independent variables.
Okay.
They say it is like if the student is going to use 2 independent variables in order to get 6 to 12 pages, then there is something wrong with the choice of the research question. Maybe it is too simplistic.
Understood. Understood. With regards to a hypothesis, Nada, I was wondering if you could give us an example of a strong hypothesis. And this is Nadizad's, I'm sorry if I'm saying your name wrong, Nadizda's question.
Any hypothesis that, like, the student is investigating the relationship, let's say, I'm going to use a school investigation, the one that I just referred to, the relationship between the period of a simple pendulum and its length. Then they can refer back to the theory, and I would say, according to the theory suggests that the period is inversely proportional to the square of, of the length, or directly proportional to the square of the length. And this is my hypothesis. It is based on the, I'm giving a very simple research question. It should not be a research question for an investigation, but it is based on the theory. It does give a detailed relationship. It does not say, it would be a weak hypothesis if it says, as the length increases, the period will increase. This is not a good hypothesis. It is very descriptive. If it's going to say as the period is directly proportional to the length, well, this is against the scientific, well-known scientific concepts or theories. So that would be a very easy to refute and say it's a weak hypothesis.
Excellent. Thank you so much for that. We have one other question about one other question from Nadizda, which is, are the teachers' comments in the report to explain and help students to get higher marks rather than to provide evidence for the teacher's assessment?
As long as I said, we do read the teacher's comments, and the teacher's comments often, they are very helpful. And if I want to give you an advice, I personally, this is what I do. I do not only put the comments at the end in a document or in the on the screen, on the IBIS screen in the comments. I put my comments as well next to the criterion. I underline, I add personalized comments. It is important that the comments are personalized. Any attempt to paraphrase the descriptors, they are they are not useful. And yes, if you defend your point of view, then many times, more often than you think, the moderator will accept your point of view. But again, if you fall within tolerance, and the tolerance, I don't know if you know about the tolerance is 2 marks for the IA. If you fall within the 2 marks of tolerance, then whether +2 points or -2 points, on normal years, I'm not talking about these last 3 years, because these since 2020, 21, and now 22, it is treated as an external assessment rather than an IA, internal assessment. But if you fall within the 2 marks tolerance, then your grading will be respected. The students will earn the mark that you have assigned to the investigation.
Understood. Understood. Great. Thank you so much for that. There was a question about, you were talking about error bars previously, and there was a question here from Venkat Subramaniam, who wanted to ask that in some cases, the error bars are too small to be visible on the graph. So is it okay if a portion of the graph is zoomed in? Is that acceptable?
Actually, yeah, this is what I referred to just at the end, is that either a note to that extent, like the error bars are too small to be visible. And I would advise my students, this is what I require from my students, I advise my students never to leave the moderator questioning about anything. Like zoom in to part of the graph and show how small they are and that you cannot really draw a maximum and minimum gradients.
Got it. Understood.
So,
there was also one last question, Nada, about students being penalized if the percentage error of calculated value and literature value is big enough. Will the student be penalized if that is the case?
No, not at all. This is not a disadvantage to the students, even in EEs. Like, you know, the EE is the ultimate big thing. Even in the EE, if the, the method leads to a big percentage error and deviation from the accepted scientific theories, the student is not penalized as long as they show awareness and they try to find solutions. They identify like with the factors, maybe their method, their approach allows for this type of deviation. But addressing this actually shows a thorough, thoughtful, independent thinking, reflective student who has deep understanding of the limitations and how to address them. On the contrary, that will boost the personal engagement if it is well done.
Excellent. All right, that's fantastic. Thank you so much for that. We have one other question where we were wondering if you had any examples of good improvement that you could point to.
Yes, the good improvement may be the size of the range of the data does not allow really for projecting the graph for a big range, you know, so the range of the data can be a problem. If the choice of a specific, if the experiment calls for a certain degree of precision to make, you know, and the apparatus used is not that precise, then the choice of the apparatus should be considered. And all of this is part of the methodology.
Okay, that's great. All right, that's all the questions that we have so far, Nada. Okay. I was wondering if you wanted everybody to move to the Padlet now for a little bit.
Exactly, yes, please, if you can share the Padlet link in the chat box, and I want your input on how we, after this, can guide our students for to prepare well for the IA. What should we do all year long to prepare them for the IA?
Excellent. So we should give everybody about 5 minutes to work on this, Nada?
Yes.
Okay.
Yes, and I will project the Padlet.
All right, thank you. And in the meanwhile, while you're all filling out the Padlet as well, if there are any more questions that you'd like Nada to address for you, please don't forget to put those in the chat and I'll read them out to her again.
My advice is to go over the exemplars in the teacher support material. You know, the teachers TSM has 8 exemplars. There is also there, you can find the students sample, you know, copy that is, you can mark it yourself, and then you can find the one that is marked by the examiner, principal moderator usually, and with comments, and then there is a report highlighting the strength and the weaknesses, and for each criteria. Those are like the exemplars, they are very important in your practice. Also, I advise like that you go through the subject reports. Every subject report has a section for the IA. They highlight the strength and weaknesses for every criterion. And then they provide guidance for future teaching.
Nada, would you like to read out some of the
Yes, sure.
that's coming in?
So definitely I read General Introduction to the IA, criteria explained with exemplar, definitely. And here as well explaining, so you need to unpack the assessment criteria with the students. What I do is I assign one for the students, an exemplar, and then they do it in first alone, then in groups, then we have a discussion around, and we read the examiner's report as well. Labs, prescribed practicals assessed due to the IA, partially or totally, depending on the task. Definitely using the IA criteria and scaffolding it, definitely, like at the very beginning of the first year is different than later on as the students progress. So scaffolding the criteria for the students, having an IA guide is definitely a good idea as well. Ask students for regular updates on the progress. This is very important, like, and I will refer to this later on. The IB highly recommends that the students are supervised all the time when they are doing the criteria. Check-in meetings with them to see where they are. It's very important to catch any methodological issues with the students from the very beginning. The students should be well prepared to write effective research questions, do lab experiments, lab reports, analyze data effectively. And yes, we have 2 years long to prepare them for that. And one of the things that we can do is to gradually move away from our cook recipe, very well structured experiments at the beginning of the first year, to that it becomes more and more independent. They have to come up with the procedure, with the method. They have to come up later on with the research question, definitely, to become more and more student-centered. Explain to students how should IA can be done, share a rubric. Definitely the rubric should be with them from day one, knowing it, using it, be familiar with it. Tell them what to avoid, what to include, continuously follow up, check their progress, definitely. Starting with a general understanding of scientific method, then discussing along with the IB criteria. And this would be a long-term thing for the scientific method, enforcing the scientific method, and then developing the skills is definitely something that we should be doing and scaffolding throughout the 2 years. I would add to this, like, teachers need to design practical work that exposes students to all the skills needed in the investigation, experiments that allow for use of data loggers, you know, experiments that where you require them to use Logger Pro, Excel, or another like software to analyze data. Experiments that require them to plot curves, to use error bars, to linearize that, and show the thinking process for linearization, using the graph in front of them and using the equation, and then use it to linearize, place best fit lines, interpret gradients, interpret intercepts. So exposing them, having them write reports where they need to tackle all of these skills in a non-threatening environment. It is important that the first time and the second time we introduce them to those skills to be formative and not summative. The practical work needs to be scaffolded to become less structured and more student-centered by allowing students to design their own experiments. So gradually moving away from typical cookbook recipes, and this is important. Throughout the course, teachers are advised to discuss extensions to class investigations and ideas for investigations related to the topics being studied. This way, when the time comes for choosing an idea for the IA topic, students are ready. And you can have like a data, idea bank for them. I have an idea bank for my students, and some of them, they use this idea bank, and some of them, they don't. We don't expect everyone to be very creative, very curious. We want them to be successful. However, the ideas, they are general ideas. They should not become research questions themselves. But giving them, if you're doing the, in any topic, whether in mechanics, in thermal mechanics, gives it, lends itself to investigation, thermal as well, optics as well, like electricity. So, and it is important to unpack the assessment criteria. And definitely, as one of you mentioned, many of you mentioned that they should not be left alone. It's not like I discuss the research question with you, you write the next time I see you around the time when you submit your first, your draft. No, they need constant supervision. However, you need to, as a teacher, you need to be ethical in the term that you do not really guide them step by step what to do, what to write all the time. It is an individual investigation. It should be independent to a certain extent. But our guidance, especially at the beginning, when they're doing their method, collecting their data, you may want them to have a first round of data and graph them before, check it with them before they complete all their data collection, and eventually discover that, oh, we should repeat, yeah. If you have any other questions, these are trying to be ethical myself as well. So my work started, and I hope that you found this session useful. It's hard to know the needs of the audience when you don't know who they are. So I hope that you are able to walk away with at least 1 or 2 tips, some deepened understanding about certain aspects of the criteria.
Excellent. Thank you so much, Nada. I'm sure everybody in the audience has walked away with a renewed understanding of physics assessments. I know I have. This was, in fact, my first insight into physics IAs and assessments. And I can tell you that as a complete non-physics educator, I've been able to walk away understanding this so much better. So thank you so much for all of the great inputs and insights and your experiences. This was extremely useful, very pointed, very precise. And thank you to the wonderful participants in the audience as well for their questions, for participating in the Padlet activity and sharing such interesting strategies with us as well. Just another quick reminder, Nada will be with you all talking about Group 4 projects later this evening, or for those of you who are in other parts of the world, in another hour and a half. She's going to be a part of a panel that's going to be talking about Group 4 projects and how you can help your students prepare for those. The link for joining that session directly is in the chat for you right now. Please make sure you access this session through this link directly. You'll also be able to attend, as I mentioned earlier, you'll also be able to attend a Toddle walkthrough today. This walkthrough will happen 15 minutes from now, and you'll be able to see what we have planned for DP educators on the Toddle platform. So make sure to sign up for that session. The walkthrough link is also in the chat. We would like to thank all of you for having been a part of Toddle's 3-week DP Thinkathon. It's been a very exciting time for us at Toddle, interacting with DP educators for the first time ever. And we've had a great time talking with all of you, hearing from you, getting your inputs, listening to your problems, and hopefully sharing some solutions that will make teaching and learning more meaningful and enjoyable in your classroom. So thank you so much for having been a part of this journey with us. There have been 3,000 educators who were a part of the IBDP Thinkathon over the last 3 weekends, and we only hope to see these numbers grow. Just as a reminder, all videos for the sessions over the 3 weekends that have happened will be available on the website for you to go back and access at any point in time. We can't wait to share with you what we've planned for DP, and would love to also have you partner with us as we build the platform. So do make sure that you click on the link to partner with us in the chat whenever you have the time to spare to come in and chat with us about the platform. Thank you, Nada, for being here with us today. Thank you, everybody, for having been a part of the DP Thinkathon. Have a lovely rest of the week. And we hope to be in touch with you as the DP platform gets stronger and better. Thank you so much for joining in, everybody. Take care.
Thank you.
Bye-bye.
Bye-bye.